Alright, good day all. Today we'll be looking at solving quadratic inequalities. There are normally two ways that you attempt to solve a quadratic inequality. The first way is graphically, where you analyze a graph to determine what's true, what's not true about your inequality. So let's get started with a quick example. So if I go right here, I get my little axes right here, and I have my quadratic function. Remember that all quadratic functions are parabolas, and so they'll either open upwards or downwards. The key points to note about the quadratic, other than the fact that it's opening upwards or downwards, is that you have to find the roots of the quadratic, or the zeros, or the x-intercepts. And so that's the first thing you have to always identify. So let's say that this right here is 4, and over here is -5 right here. And so my x-intercepts, my zeros, my roots, it kind of look like they're coming at the ground right there. At those points right here, going to be 4 and -5. So I have my function f of x right here, and the question will look like this. When is f of x greater than 0? Or, more traditionally, it is simply written as f of x being larger than 0, and that's the equation you need to solve. Obviously, what makes an inequality, tells us you have to be careful right here, is the greater than sign. Well, the greater than sign right here, is simple right here, is actually asking this question. When is y greater than 0? Well, it so happens that y is greater than 0 when we are above the x-axis. So I have going across right here my x-axis, and when you are above the x-axis, the graph is greater than 0. You can think of the x-axis right here as the water line in a pool. You've ever been to the pool, hopefully, and very simply, if you're greater than 0, it means you're outside of the pool. You're no longer in the pool. You're not wet. And so, what that tells us is, to answer this question right here, if I trace along the graph, I will note that the key point right here is the root, the 0, the x-intercept. Because at that point, we have a point of transition. The graph transitions from being above the water to below the water. And then you have another, right here, key point. That right there is your other root. Again, another point of transition. The graph again comes above the water. And again, I guess now we're happy and happy again. And in mathematics, however, whenever we're looking for a solution to an equation, what we're talking about in an interval are the x values. And so, we state the answer to our solution is starting at -infinity and until we get to -5, the graph right here is above the x-axis. -infinity to -5, the graph is above the x-axis. While, on the other hand, from 4 to infinity, the graph again is above the x-axis, parentheses. And so the solution to my graph is that whenever I'm between these two numbers, -infinity and 5, and when I'm between these two numbers, 4 and infinity, the graph is above the x-axis. So, again, I could have asked almost the same question, but with the sign flipped. So, let's say I asked this question right here for the same graph. When is f of x less than or equal to 0? Notice this time right here I'm using the inequality equals to 0. Well, at this point right here, again, the key point of transition is -5, because at -5 the graph enters the water, but this is going to be a closed circle because we're looking at an equal to. And then I traverse, as I go from -5 to 4, the graph is below the x-axis. And when I get to 4, it stops being below the x-axis, And so you're going to have another closed circle because of the equality. And so we get our answer being square bracket, square bracket from negative 5 to 4. Between these two x values, the graph is below the x-axis. The graph is less than 0. The graph is inside the water. And so once you keep that in mind, solving these things graphically is not that bad. Let's take another example. Let's take a graph that's a little bit more complicated. So I got my x and y axis right here. The graph has a asymptote at negative 2. Asymptote, a line that the graph approaches but never reaches. And the graph looks like this. So it bends approaching the asymptote. And then it comes from the other side, it goes right here, and goes up forever, and this right here is the graph of my function. And the question is, when is f of x less than 0? Less than or equal to 0? Well, in looking at this graph right here, what I have to first recognize and understand is that less than 0 means below the x-axis. And one of the things that can help you is if you simply trace the graph. So if I take out my little tracer right here, and I trace the graph on this side right here, do I ever go below the x-axis? So the answer is no. So, I didn't put my arrow. The graph goes down forever. On the other hand, if I'm tracing the graph right here, I am below the x-axis. But of course, oh, by the way, this is 1 right here. But of course, at the x-intercept, the grand transition is from below to above, and so it's only over this region that the graph is below the x-axis. The key thing to remember here is that whenever you are at a asymptote, you must use an open circle. And so the solution to this graph right here will be open circle at negative 2, and shade, 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 shade. And at 1, because of the equal sign over here, I have to use a closed circle over here. And so the solution to this equation right here is negative 2 to 1, close brackets. Alright, so one more quick example. If I have an upside down problem, what do I need to know? I need to know the zeros. So this is negative 3, and this right here is 1. And I want to know when is f of x greater than 0. No equal signs right here. Again, transitioning point, and between them, the graph is above. Again, it helps if you use your finger to trace the graph. The finger graph is above from here to here, and so we take the x values for which that is happening. And so your solution will be from parentheses negative 3 to 1. Pretty easy. So the question is, what happens when I am not given a graph, or I don't have the ability to graph? I don't feel like graphing a function. And so when you're looking at your inequalities, so you're looking at your equations, your inequalities. And so let's say I have this crazy inequality. When is x squared minus 2x, when is this less than 8? Well, you might be thinking, I don't know. And so what we first got to do is we got to find the zeros. Remember, the zeros are the key points of transitions when the graph is making that change. And so that's what you really want to do, is you want to find those zeros. And so I'm going to take the 8 over. And so I will have x squared minus 2x minus 8 is less than 0. And now to find the zeros, I have to set the equation equal to 0. Because that's how you find 0, set the equation equal to 0. x squared minus 2x minus 8 is 0. And so this factors into x minus 4, x plus 2, I believe I can fly. Anyways, and so I get right here that x is equals to 4 and x is equals to negative 2. So again, so these are our 2 points of transition. What we do then to solve this problem is we then use what is called a sign chart. Oh, by the way, I forgot to mention that this equation that I'm trying to solve is exactly the same as solving this equation. Often it is easier to work with. Often it's easier to work with the factored form of an equation as opposed to its exact form. But anyways, I'm going to create a sign chart to solve this problem I have right here. So how do I create a sign chart? First thing I have to do is I have to draw a number line. The first thing I have to do is I have to draw a number line. And on this number line, I will have my 2 zeros, negative 2 and negative 4. And again, I know that these 2 points are points of transition, where the graph makes some kind of change normally. And so what I'm going to do then is I'm going to test each region so that I can figure out what that transition is. And so what I do is I cut the number line. By the way, if you cut a string twice, how many pieces will you get? Huh? Well, you get 3 pieces. 1, 2, 3. Right. And the first piece right here I like to name. The first piece runs from negative infinity to negative 2. I'm using a parentheses right here because of the inequality. The middle piece will run from negative 2 to 4. And then the outside piece will run from 4 to infinity. Those are the 4 regions of my graph. What I'm going to do is I'm going to use a test point to try to discover what the graph is doing in each region. So I need a number between negative infinity and negative 2. Say, for instance, negative 4. So I have a test point of negative 4. What I'm going to do with that test point is I'm going to plug it into the equation. And so for my test point of negative 4, I'm going to get negative 4 minus 4 multiplied by negative 4 plus 2, and that gives me negative 8 times negative 2, which is positive 10, which is positive 16, my goodness, so that's a positive 10. And that tells me then that this region is what I would call a positive region, a plus region right here. Another way of thinking about this is that in this region, the graph is above the x-axis. The middle region, a number between negative 2 and 4, I believe 0. So I have a test point of 0. And so again, I use that test point of 0. And so that means I'll plug in 0. So that's 0 minus 4 times 0 plus 2. And that is negative 4 times 2, which is negative 8. And that's a negative number. And so what then that tells me is that this middle region right here is a negative. Again, the graph is below the x-axis. The last region, number between 4 and infinity, you can use any number. You can use 5. You can use 500. Let's go with 104. 104 is between those two, right? Right. And so I have my test point of 104. What am I doing? And so I have 104 minus 4 times 104 plus 2. Well, 104 minus 4 is a positive number. And 104 plus 2 is a positive number. A positive times a positive is positive. So that tells me that this is a positive region. Notice that I didn't actually need to work the numbers out. All I really care about is, am I above, am I positive, or am I below, am I negative? So with all of that hard work done, what I noticed right here is that my zeros my points of transition. It went from above to below to above the x-axis. Which when you think of a parabola for a while, that makes sense. That means the graph of my parabola looks like this. Above, below, and above. Now interestingly enough, I did not need to draw the parabola to get the answer. I just needed to look at the sign. This sign right here says I am less than 0. Well, if you are less than 0, that must mean you are negative. And so therefore, this is the correct region, and so this is the correct answer. And so the solution is simply negative 2 to 4. And so your solution right here is negative 2 to 4. Alright? Let's try one more example. So, let's say I have x squared. I want to solve the equation. When is x squared greater than 4x plus 12? Again, what I need are the zeros, those points of transition, those points when the graph switches places. Again, it's a quadratic equation, so to find those zeros, I gotta set it equal to 0, so I gotta first take everything over. Hopefully by now you know that whenever you take something across the equal sign, simply the sign of that value changes. And so now I can find my zeros. Again, to find a 0, it must be equal to 0. So x squared minus 4x minus 12 is 0. This factors x minus 6, x plus 2 is 0. So x is equals to 6 and x is equals to negative 2. Right? So with that being said, I am creating my sign chart. A sign chart is a number line that is designed to help us get the answer. On this number line, I will negative 2. How did I make this? I need to make this equal to, greater than or equal to. And on the other side right here, my sign chart right here, I have a 6. That cuts the number line twice. Hopefully you remember, if you cut the number line twice, and that means you have 3 pieces. The first piece will run from negative infinity to negative 2. But now I use a square bracket because of the equality. That's negative 2. The second region will lie from negative 2 to 6. And then the third region right here will lie from 6 to infinity. So with that being said right now, I can go ahead and test the first region. TP, test point. My first test point is going to be, let's go with negative 3. So I take negative 3, let's plug it into the factor form, because that's always easier and faster. And so I have my TP negative 3, and so that is negative 3 minus 6 times negative 3 plus 2. That's negative, and that's negative. A negative by a negative is positive. And so it means that this is a positive region. Now this is where the little trick comes in right here. I know that my 0 is a point of change. So if this is positive, the next one must be negative. And again, my 0 is a point of transition. So right here, if this is negative, this right here is positive. And with that right here, I have enough to get my sign chart, which takes me to my answer. There's a different way of getting those same values right here. And that's by using your understanding of your quadratic equations. In this quadratic equation right here, a is greater than 0, so it means it opens up. The graph will look like this. And it opens up right here, the graph looks like this. And I know it must go through these 2 points. Those are my zeros. I know it must go through these 2 points. My zeros right here. So, if it must go through these 2 points and open upwards, the graph has to open upwards to go this way. Notice right here it's above the x-axis, and then it has to go down here. It has to turn, and then it has to go up again. So, this is above the x-axis, so that's a positive region. This is below, so that's a negative, and this is above. Notice that the zeros, again, are your points of transition from one side to the next. And of course, this says right here greater than 0, so this right here is greater than. And because it's greater than 0, I'm looking for the positive region. And so my positive regions are here and here. And so my solution is negative infinity to negative 2. Give the region, put a u, because there are 2 regions, and then 6 to infinity. And that right there is the solution to all my problems. I got no more problems. What you get? None, right? Anyways, thank you for your time.